In this problem, you have a couple different options for sketching this graph. One of the more common options that students prefer is to actually use the slope-intercept form. And what would be involved in that is if you take your equation and you rewrite it in slope-intercept form, meaning you solve for y. So if we leave the 2y alone on the left side, we're going to move the 3x over, so we subtract a 3x from both sides, and we move the constant over, so we add 12 to both sides, and then just divide each term by 2. You get your equation in slope-intercept form of y equals negative 3/2 x plus 6. And in that particular case, you can sketch your graph by plotting the y-intercept, 1, 2, 3, 4, 5, 6, and then using the rise over run to plot a second point. So the rise is down 3, 1, 2, 3 in the negative direction, and then over 2, 1, 2, and that gives you your points that allow for the sketch of your graph. There's another method that you could choose to use on this, and that's often known as an intercept method. And what that would mean is if you rewrote this in standard form, so you have a 3x and a 2y alone on one side, add 12 to the other, so we rewrite the equation in standard form. What you could then do is you could just plot the x and y intercepts for this to sketch your graph. So basically, if you let x equals 0, that's going to give you your y intercepts. So if x is 0, we basically eliminate this term and solve for y. Divide by 2, we get y is equal to 6. So that's one possibility. Okay, the other so that gives us one set of points. When x is 0, y is 2, 3, 4, 5, 6. We can plot that point. And the next case is we let y equals 0. When y is equal to 0, again, that basically eliminates this term, and we solve for the corresponding x. 3x is equal to 12. Divide by 3, we get x is 4. 1, 2, 3, 4. We can plot that. And what you see here is we get the same equation, or the same graph, just in two different ways to find that same information.